Hello and welcome to Disaster Proof Your Containerized Apps. Today's webinar is sponsored by Portworx, Red Hat, and Intel, and produced by Actual Tech Media. My name is Scott Becker. I'm from Actual Tech Media, and I am excited to be your moderator for this special event. Now, before we get to today's great content, we do have a few housekeeping items that will help you get the most out of the session. First off, we want this to be an informative event for you, so we encourage any questions in the questions box in our webinar control panel. Not only will we have team members responding to questions during the live event, but we'll also have a dedicated Q&A session at the end of the presentation where we'll discuss in greater detail some of the top questions that you ask. That Q&A panel is also the place to let us know about any technical issues you might be experiencing. A browser refresh is going to fix most audio, video, or slide advancement issues, but if that doesn't work, just let us know there in the Q&A and we'll provide further technical assistance. Second, in the handout section of your webinar control panel, you'll find that we're offering several resources. I'd especially like to call your attention to a PDF from Portworx on running Kubernetes in enterprise production environments. Also in there, you can find a link to the Gorilla Guide Book Club, where you can get access to Actual Tech Media's great printed resources on technology topics, as well as a link to the ATM Events Center, which has our calendar of upcoming events. So I encourage you to access those resources now and share them with your friends and colleagues. Third, at the end of this webinar event, we will be awarding a $300 Amazon gift card to one lucky registrant. Of course, you must be in attendance during the live event to qualify for the prize. Official terms and conditions of today's prize drawing can be found in the handout section. Just scroll to the bottom and you'll find the prize terms and conditions link there. Finally, one of the best benefits of this event is the opportunity to ask a question of our expert presenters. And we will have, our presenters are here from Portworx, Red Hat, and Intel. So, get questions for any of them. Great time to ask them. And to help encourage your questions, we have a special additional prize for you. It's another Amazon gift card, this one for $50 for the best question. So at the end of the event, we'll look at all the questions, pick out the very best one, and contact that prize winner. And with all that out of the way, let's get to today's fantastic content. It is my pleasure to introduce you to our presenters today. We have Matt Levan, who's Senior Solutions Engineer for Portworx by Pure Storage. We also have George James, a Senior Partner Solutions Architect at Red Hat, and Brian Cadell, who's a Cloud Solutions Architect at Intel. So I'm going to turn things over to Brian to get us started.
Hello, everybody, and welcome today. Thanks for joining us to listen to our webinar. I'm Brian Cadell, a Cloud Solution Architect at Intel. We also have George James, who is a Senior Global Partner Solutions Architect, along with Matt Levan, a Senior Solution Architect at Portworx. As you all know, across the edge to cloud, which includes compute, network, storage, everything is software-defined. That's where we have been working to make the most seamless experience and deployments for our customers. You also know that today's workloads are no longer just general purpose, but tailored towards addressing specific workload requirements and needs. Move to the next one, please, Matt. Red Hat and Intel have been providing the building blocks for this digital transformation, from edge to cloud, hybrid to multi-cloud, across bare metal, virtual cloud, and edge deployments, which provides the flexibility with no vendor lock-in for our customers. Red Hat, Intel, and Portworx allows you to deploy your containerized workload where and when you need them, with the agility, reliability, and flexibility to move them anytime, anywhere. Use hybrid and multi-cloud infrastructure for your data center deployments, and organize your data and storage infrastructure to get the insights you need to maintain control over your data. We have been working with many different OEMs to create reference architectures like Dell, HP, Supermicro, and Pure Storage to make it easy to deploy on a validated platform. We're also working with data scientists and application developers to increase their capabilities in building, training, developing the machine learning models, which managed on a public cloud or a hybrid cloud platform. This platform architecture encourages AI and ML experiments and innovation, as well as simplifying the integration into the application. Next, please. Intel has been working with AWS for more than 15 years of an engineer-to-engineer relationship, which can be reflected in our shared customer obsession, constantly iterating and listening to what Amazon and their customer partners want, and delivering that in an optimized solutions built upon custom silicon SKUs. AWS and Intel have been developing a variety of specialized instances for memory-intensive workloads like SAP HANA, high-performance computing HP workloads, big data, artificial intelligence, and IoT to meet the needs of an organization today and in the future. Our focus has always been on delivering cutting-edge technology, plus delivering the highest performance at the lowest cost. We also have a world-class supply chain that enables AWS to scale appropriately with the right products based on the customer's demand. If you look at the range of AWS instances powered by Intel, we've been working together to design instances for compute or memory optimized or storage optimized to ensure demanding enterprise applications can run in an optimized and scalable manner in the cloud. The goal is to architect from the edge to the cloud so that any optimizations we make in the cloud can also benefit the edge. For examples, projects we've worked on with Amazon during the last 15 years include Habana Gaudi and their EC2 DL1 instances that leverages up to 8 Gaudi accelerators and delivers up to 40% better price per performance than current GPU-based EC2 instances for AI training and machine learning workloads. SageMaker AMI is also another that our engineers have worked with AWS to optimize ML frameworks like MXNet and TensorFlow with Amazon, so that when you use Amazon ML services, you know you're getting the maximum performance possible. That is an iterative process. We have validated performance with every software release to comprehend new features and make continual improvements. Other areas include AWS Deep Lens in the area of computer vision that have examples of healthcare patient tracking, supply chain management, and manufacturing and product improvements, along with AWS Deep Racer. Next slide, please. As you can see here, Intel has the largest number of instances available today. And as you can see, different workloads have different needs based on general purpose, compute optimize, memory optimize, accelerated compute and storage optimized instances. Also, on the left-hand side, the code names of the generations of the Intel Xeon processor from the oldest at the bottom to the latest at the top. Last, we have recently released at reInvent 22 the EC2 R7IZ instances that are available in preview today and represent our 4th generation Xeon scalable processor, codenamed Sapphire Rapids. Next slides. And last, in closing, I also would like to highlight how Intel, along with Red Hat's OpenShift platform, combined with Portworx Kubernetes data platform, is helping enterprise run their mission-critical applications and meet their needs to operate, scale, and secure their Kubernetes environment and applications like database wherever they need to run these applications with just a few clicks. Now let me hand the presentation over to Matt from Portworx.
Thank you, Brian. That's a great introduction from Intel on how Red Hat, Intel, and Portworx are working together to solve some of the problems that we're seeing today. And kind of let's jump into what are some of these challenges we're having today in IT. You know, especially coming out of the pandemic, one of the things was there was a lot of a need for being able to develop, deploy, test, and get new applications out there very quickly and in an ever-changing world. And now that we're starting to see a multi-cloud world where you might be running in a private cloud, on-prem, or in a public cloud, you know, these are new challenges that we're facing here. And then today is do more with less. One of the things that is going to be a real challenge for this year is that we're going to have cost cuttings. We're going to have to do more with less, really. And then as we move into a DevOps world, right, where developers are responsible for the full life cycle of the application, from developing it, testing it, and then bringing it into operations and production. And where did this kind of all start, right? It started with containers. Containers really brought a powerful message of being able to quickly and easily develop new applications, deploy new applications, But the problem was there was nothing that really was corralling all this so that you could easily make sure that your applications are running where they need to be, when they need to be. And this is where Kubernetes came in. It's the orchestration engine for Kubernetes. And it's a really powerful tool that allows for, making sure that your applications are running. Kubernetes is really making sure that if a switch is flicked on, that it's always checking the state of the its platform and making sure that an application is running. But then we bring in stateful applications. Now we're starting to look at, how do we bring in databases, message queues, all the different, applications. Kubernetes is very simple when you're running stateless applications. You're just running a web server or some other application where there's no state. Well, when we first started, what you would do is you already have a traditional, storage infrastructure. And you would, just deploy a container. Kubernetes has concepts to deal with storage, persistent volume claims, persistent volume storage classes, right? And you would just use the old approach of, I have a traditional storage infrastructure. My vendor has a CSI driver, which is this container storage interface. But, this is, you're kind of locking your application to that particular infrastructure. And we want to be able to do a lot more than that. But let's talk about Red Hat OpenShift here for a second, right? So, Kubernetes, if you're just rolling, a open source Kubernetes distribution, you get just the basics, right? You get container orchestration. What Red Hat OpenShift done, and it's the reason why it's the #1 Kubernetes platform, is it's gonna start bringing in all those toolings and different sets of capabilities you had in your traditional environment, right? You had monitoring, you had metering, you had the capability to do continuous integration, to continuous delivery with your traditional environment. And really, that is the power that Red Hat OpenShift brings. Is it's going to improve your developer productivity. It's going to give you insights into your data. You're going to have your monitoring, you're going to have your logging. You can then integrate into maybe your tool sets that you already have, so that you can have a monitoring tool that's checking the logging and making sure that the application is healthy. And it really is a powerful set of things. So that is what Red Hat OpenShift. So next we look into, well, let's move beyond just having your traditional storage infrastructure. You're kind of locking yourselves into, you might have some of your hosts zoned to some storage arrays. You might have other hosts zoned to other storage arrays. But what we do here at Portworx is we virtualize any underlying storage layer and make it available across the whole OpenShift platform. And it's built upon a lot of features that are very important here. So we have the capabilities to, virtualize the storage underneath it and make it available, agnostic. So you don't have to worry about, if you're running on AWS, your EBS volumes have to attach to each thing, or in Azure, your block store is attached to each worker node. So that is what OpenShift plus Portworx brings, is cloud native platform for stateless and stateful applications. Going back to OpenShift, it gives you capabilities to run anywhere, and you have a lot of choices. You can either use a self-managed instance where, you do use the installer provision infrastructure to deploy the EC2 instances and make your OpenShift cluster work in AWS. Or you can use a fully managed option like Rosa, where the cluster is being managed by the Red Hat SREs. It has a lot of tooling built in that is cloud native. As I mentioned, you might have already had, your monitoring, metering, logging tools in the past that were built for your traditional infrastructure. Well, they don't always translate directly over into cloud native. So with OpenShift, you have all that tooling built in. So you have an enterprise grade container platform ready for you. And they're continuously developing new technologies, integrating new open source technologies. We got like serverless stuff like Knative, Istio Service Mesh. These are all capabilities that are brought into Red Hat OpenShift Container Platform and are made available for you. For Portworx, we really look at it from being the best data services platform, right? Having all the capabilities you had in your traditional storage infrastructure, but being cloud native, being agnostic, being able to run in any cloud on any infrastructure, wherever OpenShift runs, we'll be able to run. And we're going to bring things like disaster recovery, data reliability, and high availability. Being able to integrate into your existing security infrastructure so that you have robust role-based access control. And then having native data protection so that you can do snapshots, clones, backups. Maybe your pipeline uses the data from production in dev so that you can make sure you're using the actual data sets that you're using after they've been scrubbed of any data that should not be moved from production into data. But this allows you to do like a clone into dev or into test so that you're really using a full stack test throughout your whole life cycle. And then in addition, having built-in day two operations, understanding that, hey, at day one, all right, deployed my application, I got my storage, but what about what happens later, right? You need to make sure that your application isn't running out of capacity, that your storage pools or your clusters are not running out of capacity. So we bring in a lot of that automation, day two operations. And so together, we give you that consistent experience across all environments, whether you are on-prem running, bare metal OpenShift with Portworx, or you're in AWS on using EC2 instances or Rosa, and then being able to, really have that full stack developer productivity. It's not like it was in the past where, a developer needs new capacity, they would open a ticket, the ticket would go through the approval process, and then the new volume would be mapped, right? We're looking at speed to market, being able to do things a lot faster so that a developer, when they need capacity, can go do this. And this is one of the powerful things about OpenShift, is that, having that capability of self-service. And then, we also, give you a highly available OpenShift container registry. It's built in, but then you could also use something like OpenShift Platform Plus, which includes Quay, so that you can have that enterprise container storage. And now I will hand it over to George to cover some more details on OpenShift Container Platform.
Thanks, Matt and Brian. I would just like to take a few minutes to do a bit of a deeper dive into OpenShift. As Matt mentioned, OpenShift is Kubernetes. It's Red Hat's enterprise-grade Kubernetes offering that provides a comprehensive solution for deploying and managing containerized applications at scale. OpenShift can run on various platforms, including on-prem, public cloud, and hybrid cloud environments. For on-prem, OpenShift can be installed and run on bare metal servers or virtual machines in your own data center or private cloud. OpenShift can also run as a managed service or self-hosted on cloud providers such as Amazon or Azure. And we also support a hybrid cloud where some applications run on-prem and others in the public cloud. We also support a hybrid cloud where some applications can run on-prem and others in the public cloud. And because all containers run the same RHEL-based image, your containers will run the same everywhere. OpenShift also provides additional tools to help you bring your applications to market faster and with greater ease, such as an integrated image registry, like Matt mentioned, Quay, networking, and data and developer services. For multi-cluster environments, we have advanced cluster management. This gives you a single control plane to monitor and manage the entire cluster fleet, no matter where they are located. Next slide, please. So let's cover operators quickly. What is an operator? An OpenShift operator is a software application that is designed to automate the deployment and management of containerized applications on OpenShift. Operators encapsulate the operational knowledge of an application or service and automate routine tasks such as installation, scaling, upgrades, backup, and failover. One of the key benefits of using operators is that they provide a higher level of abstraction and automation to the development and deployment process. This means that developers can focus on writing code and building applications, excuse me, while operators can take care of the underlying infrastructure and operations. All right, next slide, please. Now we know what operators are. Why do we need a certified operator? Well, to become OpenShift certified, an operator must go through a rigorous testing process to ensure that it meets a set of predefined quality and performance standards. This certification process includes functional and integration testing, security and vulnerability testing, and performance and scalability testing. Once an operator is certified, it can be easily installed and managed through the OpenShift Operator Hub. The Operator Hub is a central repository where users can find, share, and install certified operators, making it easy to discover, deploy, and manage complex applications on OpenShift. Next slide, please. So now let's review the 5 levels of operators. Level 1 is install. At this level, the operator can be installed on an OpenShift cluster and can be used to deploy and manage the application. Level 2 is update. This includes updating the application's container image, configuration, and other resources. Level 3 configure, which includes managing configuration files, environment variables, and other application settings. Level 4 is monitoring. This includes collecting and displaying metrics and logs, setting up alerts, and providing other monitoring functionality. And finally, we have level 5, autopilot. At this level, the operator can fully automate the management of the application. This includes features such as scaling the application up and down based on workload, self-healing in the event of failures, and auto-upgrading to newer versions. Operators that achieve a higher capability level have demonstrated more advanced functionality, automation, and management capabilities. Red Hat and Portworx have partnered together to provide the highest level of functionality for those using the Portworx OpenShift operator. And with that, I will hand it back to Matt. Thank you.
Thank you, George. So let's just cover quickly the promises of Kubernetes, right? It's being able to manage the life cycle of your applications, decoupling from any underlying hardware, flexible and adaptable, and then cloud agnostic. When we bring in, though, stateful applications, that's when things get a little more complicated, right? You might be running your MySQL database in AWS RDS or PostgreSQL on-prem. And that really, your decoupling has gone away, right? And you don't have as much flexibility. Your data is in AWS. You can't easily move it or make use of it in other locations. So this, when we look at it, we want to look at, we're kind of locked in here. We're really at a single cloud deployment model here, because we don't really have all the different features and promises that Kubernetes brings. But when we bring in Portworx, we're now going to look at decoupling those applications from your underlying infrastructure where it's running, and really bring in that multi-cloud deployment model. And this will be really evident when we start talking about the disaster recovery features that Portworx brings. So let's do a quick recap of what we've learned here, right? When running stateful apps in Kubernetes. Kubernetes is really powerful for stateless applications. They're very easy to move. They're not sticky. But when you start running, applications in Kubernetes, you're going to kind of have that stickiness where you might be locked into, your traditional storage vendor, where you don't have that visibility from the Kubernetes environment into the storage, or you don't have the capability to easily move an application from one cloud to another. And here you'll see, the myriad number of applications that are available that are stateful applications. And these could be running anywhere. We have our different clouds on the left. We have a different traditional storage in the middle, down at the bottom. And we have OpenShift, whether it's running on AWS, Azure, Google Cloud, or IBM Cloud. They could be running anywhere. And then one thing about Kubernetes, right? It, like I mentioned, is not aware of where that data is. So it doesn't differentiate when scheduling pods. So that you could have locality of data is not available if Kubernetes just starts deploying applications. It could put the application container on worker node 3 when its data is located on worker node 2. And in a traditional environment, what this would mean is that you would have to detach that volume from worker node 2, reattach it over worker node 3, so that the application could come online. This could take some time, because this is a traditional, storage process where, it has to, the node has to be zoned. It has to do a detach operation, has to do attach operation. So these are things that kind of can take some time. And what is Kubernetes is about is being able to have, quickly deploy an application and have it ready. So as I mentioned, what's missing, right, is Kubernetes is not aware of where that persistent volume is, and it could, reduce latency. It could take more time to detach. But then if we start going into data availability, so in this example, right, we have a worker node 2 with an application running and its volume attached to it. So what happens if so we have an application on worker node 3. Yeah, I think I need to back up on this one. So what we're missing here is high availability on your persistent volumes. So we have a volume that's attached to worker node 3, and it's available there. What we need to be able to do is have that high availability across multiple worker nodes. Next is volume optimization. again, Kubernetes is not aware of performance cost optimization for its persistent volumes. You can do it in a way where the storage class is defined as fast or gold, silver, bronze. But then again, that's on the developer to know which storage class it should be using. So how do we start to solve these problems? We start to solve them with IO optimized, read optimized, database optimized, random IO optimized, having a smart infrastructure. So with Portworx, we have intelligent persistent volumes that optimize the performance of stateful apps. And we'll cover in more detail how these all work with Portworx when we bring it in line here. So let's talk about data availability first here. So in Portworx, we're a storage virtualization layer. So we take underlying capacity, whether it's an AWS EBS volume or your traditional storage array, and we bring your high availability up into Kubernetes. So in the case where worker node 2 were to fail, we would just be able to easily and quickly move the application where the data already resided on worker node 1 and move the application over there and have data locality. We also would then make sure that a new replica were created on a different worker node so that you have that high availability. So again, in this case, we have worker node 3 running application where its volume is on worker node 4, but that doesn't work well. We want to have the application start on worker node 4 where its replica is for that locality. This is part of the hyperconvergence part of Portworx, is being able to, work with the Kubernetes scheduler and let it know about locality of data so that when a stateful pod starts, it starts on a node with a replica that is locally available. So this increases performance, lowers latency, and makes scheduling easier. The next thing we do is volume optimization. So anytime a Portworx uses a volume from, AWS EBS or, a pure flash array, the first thing it does is it's going to do a analysis of that drive, whether it's SAS, HDD, SSD, or NVMe. It's going to look and see what the performance of that volume is that it's using. And then if you have multiple volumes of different classes, it'll create storage pools of those different classes so that you can do optimization of your performance of those volumes, underlying volumes that have been virtualized. Another thing with volume optimization is, if you have a persistent volume out there that was left over with a retain policy and you deleted the PVC, say it's 100 gig volume or, something else. If you request a new persistent volume claim, Kubernetes may be like, hey, I have this PV that's available, but the request is only for 10 gig, but I had this 100 gig. Well, it meets the requirements. So I'm just going to bind the volume that is requesting 10 gigs to that 100 gig volume. That's not good utilization of that volume because you really only needed 10 gigs. So the other thing is if we were to, request that 10 gig volume and we might know it's going to grow to 50 gigs, 100 gigs over time, but that could be a 3-year process until it grows. So with Portworx and Autopilot, we can create rules that will monitor the capacity of that volume. And we can do this with under the storage pools that Portworx is using also, and monitoring that capacity. And you write a rule, say, hey, when I get to 80% utilization, double the capacity. So in this case, when that volume is of 10 gig gets to 8 gigabyte utilization, it'll increase the capacity to 20 gigabytes. And this is very easy to do when working with OpenShift because it has all these monitoring tools already built in that we can interact with. So, we'll know that information from OpenShift that that volume is getting to be full and we need to increase capacity. So that's some of the volume optimizations. One of the things I didn't cover is part of the tool set that Portworx brings is we'll give you different categorizations. So you could, if you know an application you're using as a database, you can have it use the DB storage class and it'll optimize the IO patterns for databases. Or you have, you're using a volume for backups that you're gonna just stream the backups to. That volume could be created using a storage class with a sequential pattern built into it so that the IOs are optimized for that application and use case. Now let's talk about some of the other features that Portworx brings. Part of that is backup and restore. Traditional backups are not cloud native aware. When you look at an application in OpenShift, it's more than just the data that is residing on Portworx. It's also the Kubernetes objects that make up that application. It could be a deployment, the stateful sets, config maps, the secrets. So you need a, cloud native application that's aware of all these different parts that makes up an application in OpenShift. And part of that is that, when you look at an application, it could be made up of these two containers, these two volumes, and, we want to be able to back them up and restore them anywhere. That's another feature that's there, is that we'll take a snapshot of that data, we'll take a snapshot of the Kubernetes objects, and we'll back them up to an S3 object store, which are then made available for restore in any other location. And disaster recovery, right? Traditional storage is not container aware. It's not aware of the other objects. Along with backup and restore, you need the application data, you need the Kubernetes objects. And there isn't something like, if you're aware of VMware Site Recovery Advisor, SRA, for being able to, make the traditional storage aware and then do the traditional storage replication. But we want to be able to have container native capabilities of doing disaster recovery. And we'll go into more detail here on how this all works. But really what this does is with Portworx, you can do either synchronous replication between two clusters that are within a metro region, so anything less than 10 milliseconds. But then you can also do asynchronous replication to a third cluster that's, maybe across from like east to west, or it could be, east to Europe, but it allows you the capability to have true disaster recovery that is container native. All right, so we dipped into what disaster recovery is a little bit, but really what is important here is there's two terms that are really important about disaster recovery. It's recovery point objective, which is how much data can you lose? In a synchronous replication, you're at 0 RPO. But in an asynchronous replication, you could possibly be in 15 minutes of RPO. And then the other one is recovery time objective. This is essentially how long is it going to take me to recover from a disaster? So tool sets like Red Hat Advanced Cluster Manager can really help to lower these times that would take versus having to manually recover from a disaster or just having scripting in place to do that. But one thing that's very important to cover here is that disaster recovery is not a backup solution. So there's a couple different ways to do disaster recovery. You can have an active passive configuration, or you can have an active active configuration. An active passive configuration is where you'll have a hot site that's active and then a standby site that's inactive, but is kept in sync by replicating the data and replicating this Kubernetes objects. And one thing you can do here is with a global traffic manager, a GTM, it'll automatically direct traffic to the active site. And if a failover were to occur, it would just redirect traffic to that secondary DR site. And then we could have an active active configuration. This is where you could have multiple OpenShift clusters all running in different data centers or clouds where, it's keeping the data in sync. So you could have, replicas of databases in multiple sites that are all being used. There's a lot of different techniques that databases use for defining who's active or if it's only a read-only. So these are some of the things that you can make use of for an active configuration. And again, the global traffic manager is the one responsible for making sure that traffic is going to an active application. So let's look at RPO and RTO from another way. Like I mentioned, disaster recovery is not a backup solution. So you still need to have backups. So this could be, especially today with ransomware being such an issue, is you need to have good backups. And ideally, your backups would be in an object block bucket so that in case of a ransomware attack, they can't also go destroy your backups. Next, we have asynchronous replication. One of the things that we need to worry about nowadays is, hurricanes or tsunamis. What if a whole region goes offline? You need to have replication that is far enough away that you are not impacted by a regional disaster. And then finally is your metro disaster recovery. This comes down to, is there a failure at a site, availability zone, a data center? But you need to be able to have your data that's with no loss of data, and then you can easily get back online. So these are the three different kind of levels that we want to do for service levels. So as someone who's been in storage a long time, we like to use pyramids, right? And part of that is, so someone who's been in storage a long time, we're used to seeing kind of pyramids of foundation building blocks. And part of that is, local high availability. As I mentioned, Portworx uses replicas. So in an AWS environment, you could have replicas in 3 or more availability zones to protect against issues in a particular AZ. So this is having, 2 to 3 replicas that are available locally. And then we have, backup and restore, being able to have, being able to back up your data and your Kubernetes objects and then restore them. It could be, to a new site, back to where they were. But, you're going to have some level of data loss because you're probably not backing up more than every 15 minutes, maybe every 24 hours. And then finally is at the top is disaster recovery. And this is tuned for your RPO and RTO. If you need to have 0 data loss, you're going to use Metro DR or synchronous DR. If there's some level of data loss or recovery that can be done, you can use synchronous, asynchronous. So these are all different levels of capabilities that are built in with Portworx. Again, so Portworx has built in to the platform capability to do backups using PX backup. Being able to do Metro DR and asynchronous DR with 0 RPO or near 0 RPO. So this is the PX DR features. So these are features that are foundational to Portworx. So there's going to be one new thing in here. So we just announced near sync DR at KubeCon North America last year. And one of the awesome features we've gotten with this is that, we used to have 0 RPO with synchronous DR, or we had RPO of 15 minutes with asynchronous, but with near sync, as long as it's less than 120 milliseconds latency between sites, we can get down to an RPO of 24 seconds. So this is a really awesome new feature that we announced and is coming this year. So, and you can see in the picture here, right? We could do, our Metro could be SF to Mountain View, but in the demo that's available on YouTube, you can see near sync going from Chicago to Frankfurt. So that's a pretty long distance to get such a low RPO. So let's cover just again, the different features that we have, right? So we have synchronous DR, near sync DR, which is new, and asynchronous DR. Synchronous DR is essentially a stretched Portworx cluster with multiple OpenShift clusters that are in a metro area with latency less than 10 milliseconds. So again, RPO is 0 and RTO is fast. And that is really RTO is dependent on how you've designed your, failover capabilities. Near sync, RPO 24 seconds, very fast, and can be much further away than Metro with as long as the latency is sub 120 milliseconds. So this would allow you to do something like east to west coast US cloud regions today. And then finally, asynchronous DR. So no limitation in latency, but it is snapshot based and will replicate on about 15 minutes. So you'll be in sync during that time. So it could be, but you can make use of these 3 things together. Like we showed here, or well, this is asynchronous. Again, just another representation of how synchronous works. One thing that is really cool with synchronous is that if you have 2 replicas, the scheduler is going to make sure that the replicas in site 1 and there's a replica in site 2. So they always have replicas in different fault domains. Again, asynchronous uses an external S3 compatible object store for the snapshots and is supported on anything around greater than 10 milliseconds round trip time. And here we can show OpenShift PXDR across 3 sites with, two sites in a metro area doing synchronous, and then the third site doing asynchronous. And lastly, I wanted to close with a success we had. So the Royal Bank of Canada was modernizing their applications, and one of their applications was a banking application that could not have any data loss. Part of this might be regulatory. Like I know in the United States, you have to have 2 sites for most banking applications. So what Royal Bank of Canada did is they deployed Portworx Enterprise with PXDR in 2 sites with Metro synchronous replication, and were able to achieve 0 RPO DR with less than 2 minutes failover in event of primary data center loss. So this is a really awesome story we like to talk about and use. I think we ran over in time here. So gonna skip the demo. It would take another few more minutes. But I wanted to thank everyone for attending. Come see us. We'll be at KubeCon Europe. We'll be at Red Hat Summit. So if you'd like to learn more, reach out and would love to talk to you. Thank you.
Okay. Yeah. So great overview there. Some of the main challenges around Kubernetes and containerized apps and solutions for those. Are you guys ready for some questions?
Yep, I'm ready here.
All right. Super. Matt, we have one here. Someone was looking to find out if there was a way to see the demo that you were going to show. So we did put that link up in the handout section. What can they see on that demo if they click on it later?
Yeah, so this is a demo showcasing both synchronous and asynchronous. So a pretty traditional 3 data center disaster recovery solution. So it's available on YouTube. The link will be in the handout, so you can go watch it at your own leisure.
Okay. Yeah. Very cool. Yeah. So, okay, everybody, just be sure to save that link. It is over there in your handout section. Matt, another one for you here. They're asking, with disaster recovery, is it recommended to have a third site to act as a witness?
Yeah, so in a synchronous disaster recovery situation, the Portworx cluster is essentially spread across both data centers. So if you don't have that third site available, you could end up with a split brain situation. So where network connectivity is down between the 2 sites, and they both think they could be active at the same time. So having that witness site make sure that in case of communication issue between the primary and secondary site, you will hopefully still have that third site available to know that everything is okay. But if they all can't communicate, then obviously probably networking to all sites are down at that point.
Okay. All right. Super. All right. Jared had a question about bridging the gap between IT silos. It's a great question, Jared, but slightly outside the focus of the crew on today. So Russell, who's also here from Red Hat, has sort of been shopping that question around on chat inside Red Hat ever since you asked it. No luck so far, but Russell, we appreciate the effort, and we'll get you Jared's contact info so you can pass along an answer if you get a good one. Matt, here's one for you. Can any S3 compatible object store be used with asynchronous disaster recovery?
Yeah, so you could use AWS S3. You could use Azure Bob Store, I think it's called, Object Store. The Google version. You could even use, something like a pure FlashBlade or any sort of hardware device. The one requirement would be that the object store would have to be accessible from both locations for it to be usable.
Okay, excellent. Matt, another one I'll direct to you here. This one's from Peter. Peter's wondering, is there a checklist available for determining when a platform or application is a good fit for an active model, or conversely require an active standby model? So I guess I'll ask that question in two ways. Is there a checklist, or are there any sort of, best practices or guardrails that you can recommend?
I will say that I think it might be dependent on what underlying database you may be using, and also just the design of the application. If you have designed the application to be active, I think it's really going to come down to how it's been designed. From a database perspective, I know there are different mechanisms for doing like high availability. And even like disaster recovery at a database level. One is where you have a primary replica, and then you'll have X number of read-only replicas. And I think that is done by like something like Mongo uses that. And then I think Cassandra will use sharding. So in that case, there'll be so many like Cassandra instance will be responsible for so much of the data set, and another one will have be responsible for another part of the data set, but they each have replicas of those data sets. I don't think there's a checklist. I'm sure if you were to go from a development perspective, there's best practices for designing an active situation, but I think it's going to come down to a lot of different factors. And I'm not aware of any like checklists off the top of my head that would be like what you're looking for there.
Okay. All right, super. Well, I think you gave out a lot of really good considerations for that, so appreciate it. Well, guys, I think we're going to have to leave it there. But Matt, Brian, George, and Russell, thank you so much for being here, putting together a really informative presentation, and for those insights in the Q&A. We really appreciate your time today.
Thank you.
Thank you.
Thank
you.
Okay, and before we wrap up, we do have one more piece of business. It's the Amazon gift card prize drawing, and the winner of that $300 Amazon gift card today is John Chitwood from Tennessee. So congratulations to John. We'll be in touch to get you your card. And with that, on behalf of the Actual Tech Media team, I want to thank Portworx, Red Hat, and Intel for making this event possible. And thanks as always for attending and for your great questions. That concludes today's event. Have a fantastic rest of your day.